All right, welcome to The Explainer. If you're going to be building the next generation of software, let's be real. You're not just dealing with code and algorithms. You're dealing with people's rights. So today we're talking about privacy, but not just as some vague legal idea. We're going to treat it as what it is, for you, one of the most fundamental engineering challenges of your entire career. Let's break down what that really means.
Now, this isn't from some tech manual or a coding textbook. This is from the Universal Declaration of Human Rights, written way back in 1948. And this is where the entire conversation has to start. Before we even think about writing a single line of code, we have to get our heads around the fact that privacy is a fundamental human right. And our job, as the engineers and architects of the digital world, is to figure out how to actually uphold that right in the systems we build every day.
So here's our game plan. We're going to start by framing privacy as a core engineering problem. Then we'll dive right into the key technical concepts you need to know to protect data. We'll also look at how the law is now dictating system design, check out a really powerful real-world application, and then we'll wrap up with the major debate that's shaping the entire future of this field.
Okay, first up, we need to shift our perspective a little bit. We're taking this big, abstract idea of privacy and translating it into a concrete engineering problem that, actually needs a solution.
This is really the central question for us, isn't it? I mean, it's super easy to say, yeah, we support privacy. But what does that actually look like when you're designing a database schema, or building an API, or configuring a network? That's the challenge we're going to unpack right now.
So how do we even begin to tackle that question? Well, in the technical community, two major schools of thought have really emerged, two different engineering paradigms for how we should build privacy into our systems.
It really breaks down into two core philosophies. On one side, you've got privacy as confidentiality. Think of this as basically locking the data inside a fortress. The whole goal is to make the data itself mathematically difficult, if not impossible, to trace back to one person. Then, on the other side, you've got privacy as control. This is less about making the data itself anonymous and more about giving the user a really sophisticated set of keys and levers. This is where you architect things like consent management platforms, or you build those granular permission systems that let people decide exactly who gets to use their data and for what, moment by moment. So let's dig into that first idea, confidentiality. A cornerstone technique here is something called data anonymization. The goal is pretty straightforward. You want to strip out or just obscure anything that could directly identify a person. That way, we can still work with big data sets for analysis while protecting the individuals inside them.
Here's a classic example of an anonymization technique called generalization. So instead of specific ages, you've got ranges, right? 10 to 30, 30 to 40. Same thing for the zip code, we only see the first two digits. Now, we've obviously lost a little bit of precision, but we've gained a whole lot of privacy. This is a step toward a property called k-anonymity, where every single person in the dataset is indistinguishable from at least k-1 other people. So here, Alice and Diana look the same based on their zip code, but we can still do useful analysis, like on salary trends.
Now, here's the thing. Making these technical choices isn't just a matter of good practice or ethics anymore. Over the last decade or so, privacy has become a flat-out legal requirement, a regulatory mandate that directly impacts every single developer and system architect out there.
The General Data Protection Regulation, GDPR, is the perfect example. For engineers, GDPR is not some memo for the legal department. It's a set of design requirements for you. It means your system must be architected to handle data breach notifications. It has to support a user's right to be forgotten. It demands that you build on a principle of data minimization from the absolute ground up. It fundamentally shapes the architecture of your system before you write line 1.
And this brings us to a really, really difficult question. We're building systems to protect individual privacy. But at the same time, governments argue that they need access to that data for national security. There's no easy answer here. But as the people actually building these systems, you are on the front lines of this debate, whether you like it or not. You're deciding through a code where that line gets drawn.
So let's look at a real-world case where privacy-enhancing tech isn't just protecting personal data, it's actually being used to uphold one of the most fundamental democratic principles we have, the secret ballot.
This is how something called a mixed network works for e-voting. Just imagine everyone puts their vote inside an identical, layered envelope, like a Russian nesting doll.
The first server peels off the outer layer, shuffles all the votes, and then passes them to the next server. That server does the exact same thing. By the time the votes get to the end of the chain, it is cryptographically impossible to link any specific vote back to the person who cast it. It's just a beautiful piece of engineering that directly supports a core function of democracy.
And finally, let's look ahead. Because for all the incredible progress we've made, the most intense, high-stakes debate about the future of privacy is happening right now, and it strikes at the very heart of everything we're trying to build.
You see, the central tension is this. The very same strong encryption and anonymization tools that protect journalists and activists and frankly all of us can also be used to shield criminal activity. And this has led to governments all around the world demanding backdoors or some kind of special access to encrypted systems for law enforcement.
But, and this is a huge but, the overwhelming consensus in the computer science and cryptography communities is that you simply cannot build a door that only the good guys can open. It doesn't work that way. A backdoor is by its very nature a vulnerability, and once it exists, it's not a matter of if it'll be exploited by bad guys, but when. In cryptography, there's just no such thing as a key that only works for the good guys.
And that leaves us with the defining question for your generation of engineers. Which risk are we willing to accept? The risk of creating spaces that are totally beyond the reach of law enforcement, or the risk of building systems that are inherently vulnerable to absolutely everyone? There's no simple answer here, but it's a question you, as the future architects of our digital world, are going to have to confront every single day. That's The Explainer.